Our next speaker is Numan from Red Hat. He's going to talk to us about OVN issues seen in the field and how they were addressed.
Thanks, Ben. Hello, everyone. My name is Numan Siddique. I work in Red Hat Bangalore, and I contribute primarily to OVN. So the topic of today's discussion is I would like to present what are the issues we have seen in the field when we have deployed OVN, and how we have overcome that or addressed that. Okay, so as I mentioned, this is what we are going to discuss today. What are the issues we saw and how we addressed, and hopefully we'll discuss some of the future improvements as well. Okay, so deployment normally, we have OpenStack deployment with OSP 13, which is the Queen's version of upstream. We have deployed vSwitch 2.9 and OVN 2.9, and later we moved to OVN 2.12. Okay, so before getting into the issues we have seen, I would like to just briefly give an overview of how ovn-controller looks like. The ovn-controller is the process which runs in each compute node or each chassis. And as you can see here, it just has one while loop. I'm talking about here is pre-212. It has a while loop, and any event happens in the open OVN southbound database, or any event happens in the local OVS database, it wakes up, it calculates all the logical flows depending on the state of the database, and it checks for any port bindings which needs to be done, and it also handles any packetings which have come from vSwitch, and then it finally, and it programs the OpenFlow flows. So this happens every time the loop wakes up. Yeah, so on the left side is what I said, before the incremental processing engine support was added. And the right side is what you see when we have incremental processing support in OVN, thanks to Han. And so here what we do is we don't calculate everything. We calculate only based on what changed in the database, so that we don't do a full recomputation of the flows. So it handles incrementally depending on what has changed. Okay, so the first issue, what we have seen is we see a lot of ovn-controller 100% CPU issues. So one of the reason is each ovn-controller, it connects to the southbound database, and the ideal code, it sends a probe request every 5 seconds to the DB server. It's more like a echo request, and it expects an echo reply. And if it doesn't get an echo reply, it thinks that the TCP socket connection is broken, and it breaks it and reconnects it. So if it happens that the whole deployment has a lot of logical flows and have a lot of logical switches, and if the main loop takes more than 5 seconds to do the computation, it breaks that. Finally, after at the end of it, it breaks the connection, thinking that it has lost the connection, and it reconnects it. And this process just continues. It results in a snowball effect. So the solution for that is to increase the inactivity probe interval. So we have increased from 5. The default is 5 seconds to 180 seconds, just to be on the safer side. So this is very common. We have seen. You won't hit this initially, but as you hit the scale and more VMs or logical resources comes up, you will eventually hit it. The next issue is also very similar to that, except that the same thing even OVSDB server does to all its clients. It sends the periodic echo request every 5 seconds. That's a default value, and again this results in a snowball effect. So again we have to configure to a higher value. And the third issue is seen again. OVN-controller connects to the local vSwitch as an OpenFlow connection. And there also there is an inactivity probe interval, which is sent every 5 seconds to the vSwitch. And again, if ovn-controller takes more than 5 seconds, that connection is broken, and it again reconnects to the vSwitch and starts reprogramming the flows, and it results in an indefinite loop with consuming 100% CPU. So for all these things, for this case, we did not have any configuration option, so we just had to add a small patch to add this support. So for the other two, we already had the support. We just need to configure it in the database. Okay, so this is one issue which we saw is like, again, OVN controller takes more than 5 seconds to recompute. And a VM sends a DHCP packet, for instance, like OVN has a native DHCP support, and it has its own pin control module, packet in module, which handles the it handles the DHCP request and responds back. Now, like when it wakes up, when the packet in comes, it wakes up, again it recalculates the flows, and by the time it replies back, it's too late. The VM thinks that it has lost the packet, again it retransmits. And this is what we saw in the field, and it also leads to a snowball effect. So to address this, what we did was like we added a thread in OVN controller specifically to handle the packet ins. So it's a separate thread. It will only handle the packet ins, and the main loop of the OVN controller will not wake up because of that. So this kind of mitigated this issue. So we added the support to the upstream, and we also backported it to 2.9 to have this support. Backport in the Red Hat downstream version, not in the upstream. So continuous. So so these issues again we saw like your deployment. You may have some physical switches which could be sending GARP packets. So in OVN we have logical flows where to learn the GARP packets and store it in our MAC binding table. And so whenever this packet in happens, again logical flow process OVN controller wakes up. Again it does the recalculation. So and it results again in the snowball effect. So this issue, to address this, what we already had the solution upstream, which was the incremental processing support. So we just took it, and we started using in our downstream products as well, so that we mitigate this issue. And yeah, OVN controller doesn't do. And also like for every GARP packet, like it was sending the packet ins, that is too much. So we added some logical flows, which translates to physical flows, which it will learn the MAC bindings, the GARP packets only if required. If we already have a MAC binding entry in the southbound database, we don't do that anymore. The packet is just ignored or dropped in the vSwitch level. So this also like helped in saving the CPU usage. Okay, so this is an interesting issue which we saw is like in the case of OpenStack triple O deployment, we deploy OVN DB servers as active passive using pacemaker. Like you have one master node which runs OVSDB server in the active mode where it allows write transactions, and the other two OVSDB servers, it's in standby mode and it will be replicating from the active one. So if suppose we use a VIP, and that will be like the master IP, and all the OVN controllers will use that VIP. If suppose the master IP goes down for whatever reason, the pacemaker moves that VIP to another node, and all the OVN controllers reconnect to the new location. So there is a small timing window wherein it could happen is that OVN controller connects to the new master, but still the OVSDB servers are not promoted, which means they are still not in the active state, and they have the read-only connection. All the some of the OVN controllers have read-only connection to the southbound database, and they never break the connect. They don't detect it. So if OVN controller has to do some write transaction to the southbound database, it sends a transaction to the OVSDB server, but it fails because the connection to is read-only. Ideally, OVSDB server has become master. It should have allowed the write transaction, but there was a small bug in OVSDB server. For the older connections, it was not applying this active variable. So it was a small fix, and we had to fix it. So the result of that was in certain compute nodes where it had read-only connection, when the VM comes up, OVN controller tries to do a port binding, but it fails. So the VM never, in the case of OpenStack deployment, it never comes up, and you don't have connectivity to that VM. Another issue which we saw is similar to the previous one, just that OVN controller has to do, as I mentioned, that it has to update the MAC bindings for any GARPs it sees, and when the floating IP or the Yeah, when OVN controller, learns the MAC binding, the issue was that it would not write to the DB if it was learned more than a second. So there is a timer we used to ignore the value if it was learned 1 second before. And that was also resulting in MAC binding failures. So finally, we figured out that this is the reason, and we had to just remove the code to remove that condition that you just update the MAC binding even if the packet is older. It's like pin controller thread gets a packet in, it learns the MAC binding, but then the actual OVN controller process is the one which has the ideal connection to the southbound database server, and it has to write to the DB, and there you could have some delay. So I think this one is also very similar to that, wherein in a deployment wherein a VIP was used by the customer and VRRP protocol was used with keep alive D, and when one of the VM which has an active IP goes down, the keep alive D configures it to the new VM, but then it sends out a GARP packet which OVN controller has to learn and update. And we saw this like, as I mentioned that it discards the packet if it's older. Okay, so this is one issue which we found in conjunction flows. Like if you have, as it's shown here, that if you have a few logical flows with various possibilities, you have a set of input matching with a set of IPv4s and TCP destination, then it actually results in conjunction flows. But OVN controller was not handling it properly, and because of which, like it's basically used in the case of ACLs. Or security groups in the case of OpenStack, and it was not behaving as expected because OVN controller was not programming properly. And we kind of fixed this issue initially by just disabling conjunction, and this resulted in like huge logical flow run. Like earlier, it used to take like 4 seconds to complete the computation, and it was taking like 20x, 80 seconds, if it has so many conjunction to calculate. All that was because like expression module of OVN controller, which does this conversion, it was taking more time. And we fixed that thanks to Ben with this suggestion, which handles a proper action to resubmit to both the conjunctions, and finally the proper conjunction would match and the packet will go through. I think this is what I had in terms of issues which we saw in OVN in the deployments. The main issue, as you have seen, is the bottleneck is LFlow run. If it takes a lot of time, then OVN controller can take up a lot of CPU, and it could result in a snowball effect. So we need to so when we did some profiling, we did see that the expression module, like it is spending a lot of time in malloc and its friends in allocating it. So there are a lot of string operations there, and that was taking a lot of time. But we did not spend too much time, how to improve it. So one way we could address is that improve that expression.c, but it's very stable and it's nicely written. I don't know. So maybe we can cache this expression passing to solve this issue, so that when OVN controller learns, it doesn't take so much of time in doing a flow, translating logical flows to open flow rules. Other option is like we could further improve our incremental processing engine. Yeah, I have a slide for that. Yeah, we can improve further engine. Right now, we have certain cases wherein an event happens and incremental processing engine thinks that it can't do incremental processing of that, and it falls back to the old recompute mode, and it again it could result in logical flow run taking more time. So there are some use cases, like if you just create a logical switch or a logical router, the full recomputation could trigger, or a port binding happens, it could happen. I mean, there are certain cases, and we can address it, and we are working on it, and try to improve it further so that we apply all incrementally, and we only recompute, only when the incremental processing engine thinks that, yeah, we need to recompute. Otherwise, otherwise the data which it stores is out of sync or it's not correct. So other things like we think like in OVN which we can improve is like debugging. So all the issues which we saw, like it was really a bit tough to debug, mainly to follow the flows and all. So maybe if we have some tools which we have already some tools like OVN trace, dtrace and all, which helps us in like mapping or logical flows to the actual open flow rules. But it would be good like if we have further tools. And Dumitru worked on a few of those, some of the patches to improve that, and we can definitely improve there as well. So we had this thought that maybe it would be helpful, like if we have a separate, instead of having a pin controller thread, we can have a pin controller process, a separate process. Right now what happens is that pin controller thread doesn't have its own ideal connection, but it rather shares with the actual no, it doesn't share, but rather OVN controller main thread has the ideal connection, and we maintain a local cache which copies between this to that. So that could be avoided if we have a separate pin controller process. It could have its own ideal connection, but then we could have an issue of scale wherein the number of connections to the southbound database would now multiply just by 2. And if you have a bigger deployment, you might end up in issues. So that was, we can probably think further about that, how to improve it. The other option is we could consider DD log as well, but we have a session on that, and hopefully it will be covered there. I think I had these many slides with me. I finished a bit early. If you have any questions.
Let's thank our speaker.